Hello, everybody. Welcome back. Today, we're looking at the fundamental trig identities. So we've got a series of different identities we need to look at, primarily those that we've already seen. Obviously, starting with the reciprocal identities, which we started the class with, starting with cosecant of theta, which is equivalent to 1 over sine theta, okay? And then, of course, you've got secant theta, which is the inverse of the inverse of cosine theta. So that's the same thing as 1 over cosine theta. And of course, you have the cotangent, which is the reciprocal of tangent, as in 1 over tangent theta. So these are the ones that we've talked about in the past that you guys should be very familiar with. Next, we're going to move on to the tangent and cotangent identities or ratio identities. These, again, you should be very familiar with because we've talked about these multiple times. We've looked at the graphs of them and so forth and so on. So starting off with the tangent theta, you know tangent theta involves the ratio of sine theta over cosine theta. And likewise, its inverse, cotangent theta, is cosine theta over sine theta. So as we get into proving these trig identities, basically you're recalling previous knowledge. You're using previous information and using these substitution in order to be able to prove these trig identities. So guys, the next part of this that we're going to go ahead and move on to is, again, another set of trig identities, but this one involves the graphing, okay? And so you should be very familiar with this too. And this one has to do with the negative angles. And what I mean by that is when you look at the graph of sine, cosine, and tangent, okay, you have to think about what type of symmetry they have, okay? And so when you look at sine theta, cosine theta, tangent theta, they have these symmetries that allows you to get different values depending on whether or not the function is odd or even. So for example, sine is an odd function. So when you take the sine of a negative angle, it would equal to the opposite sine of that angle. So for example, if you were to take sine of negative pi over 2, that would give you a negative of the opposite of sine, a negative sine of pi over 2. So, you know, negative 1. And so next, cosine theta, okay, cosine negative theta is equal to cosine theta, because here, okay, whether you're talking about positive angle measure, negative angle measure, it's an even function, it will be the exact same value. And then while tangent of negative theta will give you negative tangent of theta. Why? Because just like cosine, tangent is an odd function, guys. All right. So now we're going to move on to this next set, guys, involving the Pythagorean theorem. Now, and before we get to the actual trig identities, okay, we need to go back and look at the Pythagorean formula. X squared plus y squared equals to r squared. Remember, x and y have to do with the legs of the triangle. R has to do with the hypotenuse, with the radius, and we're talking about a unit circle here. So here, guys, listen, if we were to simplify this by dividing both sides or every single term by r squared, this would simplify to x squared over r squared plus y squared over r squared equals to 1, okay? Now think about this. If we go on the side here, we discussed previously that cosine theta is equal to x over r, okay? You see how I'm going back to previous knowledge? Sine theta is equal to y over r. So if we were to do a quick substitution into this formula right here, that x squared over r squared would therefore become cosine theta, cosine squared theta, plus sine squared theta equals to 1. And just like that, guys, you have your basic Pythagorean identity. This one, you need to memorize it. You need to know it by heart. This is one of the most basic Pythagorean theorem. And you will use this, guys, over and over again. You could solve for cosine squared theta. You could solve for sine squared theta, and so on and so on. So this is one of the ones that we're going to use over and over again, okay? So let me go ahead and encapsulate all of this for you into the basic Pythagorean identities, okay? So the Pythagorean identities, like I mentioned on the previous step, is starting off with cosine squared theta plus sine squared theta, and that will equal to 1. And this is the one, guys, you must memorize, okay? You must memorize it. All right. Now, the next one is 1 plus tangent squared theta is equal to secant squared theta, which I am going to explain to you later on. I'm going to actually show you how to simplify that to get to secant squared theta. And then last but not least, we have cotangent squared theta plus 1 is equal to cosecant squared theta. I will prove both of these as to how they become secant squared theta and cosecant squared theta, okay? So now, guys, when you are proving these trig identities, here are some rules to follow, okay? I'm just going to give you some of these rules, okay? They're not in any particular order, but these are some things to keep in mind, which will help you to get through these trig identities. Number 1, only work with one side, guys. You don't need to work with both sides. You only need to work with one side so you can get to the other side, okay? I like that. Okay, number 2, converting all terms, okay, to sine and cosine, guys. You're converting all terms to sine and cosine to its simplest form so that it makes more sense to you because you're comfortable with sine and cosine. And so if you can do that, by all means, go ahead and do it. Sometimes you don't have to, but doing that, guys, actually helps with the process. Now, here's another one. Start with either, okay, side of the equation. Usually they want you to start with the more complicated side, okay? So number 4, it may be easier, okay? I'm trying to write easier here. Okay, I will get it right. All right, this is what happens when you're working late. It may be easier to go ahead and start with the more complicated side. So guys, you're unraveling one side of the equation to become the other side. You're unraveling one side of the identity to become the other side, okay? So remember, stay on one side, simplify one side to get to the other side, guys. You do not work with both sides at a time. And then last but not least, number 5, guys, okay? Listen, guys, make substitutions, okay? Make the appropriate substitutions. Remember, this is all about substitution. You are using previous knowledge to get through this, so make the appropriate substitution. Like earlier, I told you tangent theta is equivalent to sine theta over cosine theta. So you have the previous knowledge, so use it to help you prove these, okay? So make substitutions using previously proven identities, guys, in order to get through this. Now, keep in mind too, we're not just within the context of trig. Remember, some of the same properties that apply in algebra apply in trig. It's just that those properties, we're using sine, cosine, and tangent, okay? Whereas in algebra, we're just using, you know, your basic variables and equations and stuff like that, okay? So guys, make the appropriate substitutions. It actually helps to do that. And by the way, guys, if you should falter, okay, you choose a substitution which doesn't work out, just scratch it up and start all over again, okay, with a different substitution. But obviously it is doable, so use that previous knowledge to help you get through the problem using substitution. Don't forget, guys, we also have the factoring, the properties of equality, you know, adding, subtracting to both sides, the multiplication, division property. Guys, all of those, you're going to use them to prove these identities, okay? So as promised, the first one I'm going to try to prove is that 1 plus tangent squared theta is equal to secant squared theta. So in order to prove this, I'm going to go to the more complicated side. Which one is more complicated? It looks like the left side is more complicated. So I am going to unravel that side, okay, in order to get to the other side. So what am I doing first? I am going to change tangent squared theta to sine cosine theta, okay? Tangent is sine squared theta over cosine squared theta. So now that I have that, I have a 1 plus sine squared theta over cosine squared theta. I'm adding basically two fractions. I need to change that one to a unit fraction. So as a unit fraction, it's going to become cosine squared theta over cosine squared theta. Okay, guys? So if that is the case, listen to this. When I add them together, because I have to multiply the denominator and numerator by cosine squared theta, so I can have like denominators, this will become cosine squared theta plus sine squared theta over cosine squared theta equals to secant squared theta. Notice, guys, the right side is not changing. It's just the left side that is changing. I'm transforming the left side so it can become the right side, guys. Now, on a side note, okay, here comes the previous knowledge we talked about earlier. Using previous knowledge, using the appropriate substitution. What did we say earlier? We said cosine squared theta plus sine squared theta is equal to 1. And what do you do in the numerator, guys? Cosine squared theta plus sine squared theta. And what is that equal to? 1. So we're going to substitute 1n for the numerator. Now, guys. So if you substitute the 1 and for the numerator, you get 1 over cosine squared theta is equal to secant squared theta. So guys, look, what's 1 over cosine squared theta? Secant squared theta. And just like that, guys, you are done. All right, so guys, here comes the next one. Yeah, I promised I was going to go ahead and show you this, okay, prove these Pythagorean identities. So here comes the second one. Cotangent squared theta plus 1 equals to cosecant squared theta. Now, again, the more complicated side is the left side. So we're going to transform the left side to get to the right side, okay? So start with the basics. Cotangent squared theta is equivalent to the ratio of cosine squared theta over sine squared theta. And then plus that 1 equals to cosecant squared theta. Now, again, guys, change that 1 to a unit fraction in terms of sine or cosine. Since the denominator is sine squared theta, we're going to go ahead and change that unit fraction to sine squared theta over sine squared theta. In other words, we're trying to make the denominators the same. So once we accomplish this, all we have to do is keep the denominator and add the numerators together, guys. So when we do this, what are we going to end up with? The denominator is sine squared theta. And in the numerator, we're going to end up with cosine squared theta plus sine squared theta. Okay, guys? So when you do, okay, hold up a second. There we go. When you are doing this, guys, keep in mind, you are using information you've used previously, okay? So right here, what do you notice in the numerator? Again, here goes that cosine squared theta plus sine squared theta. And what is that equal to again? Cosine squared theta plus sine squared theta, that's equal to 1. So we're going to have to do our substitution. So go in the numerator, substitute that 1 in for cosine squared theta plus sine squared theta, okay? And so that's going to give you 1 over sine squared theta, okay? And what is 1 over sine squared theta? Hello, that's cosecant squared theta, because that is the inverse, guys, of sine. Hello. And just like that, you're done. So you've actually transformed the left side so that it becomes the right side. That is what we're trying to do here, guys, okay? So I'm going to do a few more examples with you guys. I think I'm going to do what? 3 more examples with you guys, and then I will be done with this video, okay? So here we go. The next one we're going to do is a basic one where you're just going to have to simplify this. And so when simplifying these guys, you're not proving one side to the other side. You're just going to simplify just like you would simplify a fraction, okay? So on this one right here, we have sine theta times cotangent theta. Again, break up the more complicated part. What's the complicated part? Cotangent theta. What's the ratio for cotangent theta? Cosine theta over sine theta. Guys, you're just multiplying two fractions, cross multiply it out, and what are you left with? Cosine theta. Yes, just like that, you're done simplifying the problem. Think about simplifying fractions. Think about simplifying rational expressions and so forth and so on. Same thing, guys, okay? So next one, number 4. Sine theta over 1 minus cosine squared theta, okay? I forgot my square in the numerator for some reason, okay? So we need to fix that right there. Now, guys, this one right here, I want you to think really hard, okay? On this particular problem, if you notice carefully, you have 1 minus cosine squared theta in the denominator, all right? So let's say you were tempted to factor this into 1 minus cosine theta times 1 plus cosine theta, because this one right here, guys, is a difference of squares. The question you have to ask yourself is it going to lead you anywhere? That's the big question, okay? So if you look at it carefully and you're like, well, wait a minute, this is not leading me anywhere. So what do? You backtrack, seriously, you backtrack. And you go and ask yourself, is there a better way to do this problem? Is there a better way to simplify this one, okay? So, let me see here. All right. Something's going on with this one. Yeah, okay. So guys, listen, right here, let's go ahead and factor. Let's see what happens. Is this going to lead us anywhere? If we do 1 minus cosine theta, and then 1 plus cosine theta. 1 minus cosine theta, 1 plus, what is that going to do? Is it going to do anything? Is it going to lead us anywhere? Is it going to be able to simplify anything? No, it's not going to simplify anything. So since it's not going to allow you to simplify anything, you need to backtrack. Go back into the problem, guys. Try something else, okay? Now, let's think about the numerator. Sine squared theta. What do we know about sine squared theta? We know that cosine squared theta plus sine squared theta is equal to 1. So once you get to this point, remember earlier I told you guys, you can actually solve, okay? You can solve for cosine squared theta, sine squared theta. So I'm just gonna go ahead and solve for sine squared theta using the properties of equality. So what am I doing? I'm subtracting cosine squared theta from both sides. And once I subtract the cosine squared from both sides, what am I left with? Sine squared theta, look at that, is equal to 1 minus cosine squared theta, shazam. And what do you notice is in the denominator, guys? 1 minus cosine squared theta. Now we're on to something. You see what I'm saying? Now you're onto something. So now you're going to go ahead and do that substitution for sine squared theta, which is 1 minus cosine squared theta, okay? And then simplify it. What do you get? 1. And that's it, guys. Yeah. So as you can tell, guys, the process takes time, okay? But because you have the previous knowledge, it's not too bad. You just got to know which one of the trig identities or the basic properties you need to use in order to prove these, in order to simplify them. That's basically what you're looking at, okay? So now, guys, we're going to do one more problem, and then we'll be done with this. As you do this, guys, keep those basic rules in mind, working with one side, making sure you're using the appropriate substitution. And remember, if you should falter, just go back and start the problem all over again, guys. There's nothing wrong with you starting the problem all over again. So here comes another one, guys. It's cosecant theta times 1 minus cosecant squared cosine squared theta, okay? And you have to go ahead and simplify this, okay? So guys, listen carefully. In the previous problem, remember, we just solved this, okay? We figured out that sine squared theta is equal to 1 minus cosine squared theta. So we're gonna do the substitution for it. We place that 1 minus cosine squared theta with sine squared theta and multiply it by the cosecant theta. Now, cosecant theta is, remember, the inverse of sine theta. So 1 over sine theta would represent the cosecant theta. And of course, sine squared theta, you can rewrite it as sine theta times sine theta. And what happens? You simplify out sine, cross simplify. And what are you left with? Just sine theta. And guys, just like that, seriously, we're done, okay? So that is proving the trig identities. Until next time, guys, bye.